Welcome to this tutorial on implementing EasyTarget into Unity's third-person example. EasyTarget is a modular and designer-friendly system for target selection. The first thing we're going to do is start a new project using Unity's third-person controller example. The first thing we're going to do is go to the package manager, and we're going to import two packages. One is EasyTarget, and the other is a food pack, optionally, by Mummifier Studio, which is free in the Unity Asset Store. Now we're going to add a new physics layer for the targeting system to use. We also need to make sure that this layer doesn't interact with any other layers, which we can do by modifying its collision matrix. Once that's done, we're going to create our config files for EasyTarget. These are data files that we'll modify to fine-tune the system later. We're going to start off with the culling config, which is the first step, and is a configuration for what order and how targets are removed from the culling process. For this, we're going to create three configs, one called enabled, one called infrustum, and one called visible. And these config files are going to be put into the culling config in the order that we want them to cull. In this case, we want them enabled, infrustum, and visible, which checks that they are first enabled and working within the camera's frustum and not occluded by another object or target. You don't need to include all of the culling configs. However, these are a good pre-optimization for a targeting system. The next thing that we're going to do is create a priority configuration, which is the actual meat of the system. These configs are what prioritize and value the targets. Each config calculates a value based on world data from the target collector, and these values are combined to output a priority for a target. For this, we'll create one that is called world distance, which we'll use for the distance from the player to the targets. And we're also going to use screen center distance, which is how far the targets are from the center of the screen. Next, we want to add our eyes to the player, which is our target collector. It is the reference for world and user input, and it is the main interface that using targeting will work through. Here, I'm just going to add the target collector to the player prefab, and I'm going to set its visibility layer mask to target and to ground. These are the layers that will occlude the targets. We also want to set the culling config to the culling config that we just created. Next, let's create a new child transform under player camera root, and we're going to change its layer to target. This script is what makes sure that targets are within distance, and it has to be on the targeting layer, so it's worth putting on its own transform. Here, I'm going to go back to the player armature, and I'm going to connect the distance color to the target collector. I'm also going to set the max world distance to 20, which is going to change the size of the sphere radius. Only targets within the sphere are going to be collected. Alright, so now we got to handle the targets. First, let's make a new script. We'll call it Target Manager. This script is going to ask the targeting brain to calculate targets for us. For this, we're going to want to make sure that we're including EasyTarget and also system.link, which we'll use for list collections. Next, let's create a public property for the priority config. We'll also want a private reference to the target collector, and lastly, an initialized list of selection targets. In start, we're going to get our target collector from getComponent. We're also going to set the target collector's screen origin reference to its own screen center reference. Next, we're going to create a new function in the update event that we're going to call calculate target priorities. We're going to get our list of selection targets from the targeting brain using our priority config and target collector. This function is what actually processes the targets and queues them up with a priority. This next step is not necessary, but if we do want to debug our outputs, we'll want to set that here. We're also going to set the world origin to our player's position. Let's add our new component to the player and set its priority config to the one that we created. Returning back to the main scene, we're going to connect the camera to the camera reference in the target collector script. Now let's create the targets. We're going to create a new kind of target called an info target that inherits from target. Its only member is going to be a public string called display name. Now we're going to make the prefab for the target. First, we'll create a new sphere game object, rename it target, and add the info target component to the game object. We're going to remove all of the rendering components, and we're also going to set its layer to target. Let's zero out its transform and make it a prefab. Oh, and the sphere collider should be set to trigger. We're also going to add a rigid body component because the parent has one. This is to prevent it from becoming a compound rigid body. This is only necessary if the parent has one too. Now let's add some fruit to the scene so that it can be something we can target. Now let's make our food targetable. We're going to add an instance of target to each one of our food as a child. For each of the food items that we've added, we're going to want to add a mesh collider. We're going to want to make the mesh collider a trigger, remove the sphere collider, and then set the mesh collider to the mesh asset from the food. We're also going to want to give it a display name. Once that's all done, it's time to create the target display asset. We're going to drag a new TextMesh Pro asset into the scene. This is going to be our display object. We're going to set its Y pivot to negative 0.5 just so that the display shows up over the food. Now, let's add a look-at constraint and set its source to the camera's transform. We're also going to set the Y rotation offset so that it faces the camera correctly. Nice. Okay, now we need to only show it when we look at it. Let's include TextMesh Pro, and let's create a reference to the TMP asset. We're going to add a new function called Display Best Candidate. We want to set the target collector's current target to the most optimal target given by the targeting brain. If the target collector does have a current target, we're going to set our text mesh text to its display name. We'll also set the text mesh transform to the target collector's current target position. Let's make sure that it runs the code, and then let's also accommodate for if nothing is selected. Let's connect the reference to the display text, and just to see if everything's working, let's also add the debug script. Everything should be working now. As you can see, the targeting system is choosing the targets that is both close to the player and close to the center of the screen. The configurable part of the system comes with modifying the curves and influence of the priority elements. By bringing the influence on world distance down, we favor things in the center of the screen. Thanks for watching this tutorial on implementing EasyTarget. If you have any questions, feel free to ask in the comments, or join the Discord linked in the information section.